All right. What's going on? All right, so we're going to get out of my comfort zone today and look at some Linux malware that Tony gave me. I have no idea what this is, but it looks like it's pretty beginner friendly. So even though, I'm primarily doing Windows malware analysis like all the time. Hey, ZeroXSec, how's it going? I still want to get better at other areas of malware analysis, including Linux/Unix/ OpenBSD/ whatever malware analysis. So a lot of these types of ELF files that you'll commonly find in things like Malware, Bazaar, whatever, are often derivations or, repurposing of things like Mirai, which is a very common, it's not a Mirai sample, I don't think, which is good because I was just about to say that's kind of like every malware sample there is, or that's like commonly spreading across the internet with, SSH brute forcing, Docker container infection, you name it, is usually like some variant of Mirai. So I think this is not Mirai based on what I've seen thus far, but I didn't want to do too much because I didn't want to, go ahead without y'all. And there is some virtual machine detection in here, so I think it's probably... You hate Twitch? Why? Port Buster. I was actually looking at probably dual streaming on YouTube as well, so I don't know if I'll move over to that in the future, but it might be a good thing to make note of if folks aren't like a huge fan of, this single platform. Okay, so I'll show you what I did thus far. Multi-streaming is meta. Yeah. It's also like more difficult because then I have to look at two chats and then, it can get a little bit hairy, but I'll probably give it a try soon just so, I can work on gaining audiences and using the subscriptions that I have on YouTube and whatever. Do stay on Twitch though. It's the only place I can chat with some sort of privacy. Still hate Twitch. Got it. Nice. Chat merging. Yeah. I think there's like a lot of stream platforms that I could probably use for that. So definitely good thing to keep in mind. Okay. So so this is IDA. For those of you who are not aware, this is IDA 9.2. So I'm just messing around with some of the newer versions of IDA. The only thing that I found with the newer versions and the current versions of some of the plugins that I'm using is they're phasing out the PyQt5 support in favor of PyQt6. So there's a bunch of plugins that I had in my plugins folder that I didn't use this Windows machine for a long time, but I wanted to use it for this stream just because I didn't want to accidentally infect my Linux machine that has all my static RE tools on it. So yeah, I figured this would be something we could use instead. And when I installed the newer version of IDA, then I found, it was a bunch of broken stuff, whatever. So, but we'll just deal with it. It's okay. So getting back to this sample here. Hey, Congo X64, how's it going? Sorry, miss why we're using IDA versus... Just using IDA because I haven't used it for a while. It also has some features that I'm going to show that I used for this sample that I found to be quite useful. So that's a good segue into getting to our start function here. So upon opening the sample, there was little to no markups. And then if I go to the imports tab, there's no imports whatsoever. So this is essentially completely statically linked, which basically means that they've just set compiler flags in the compiler and linker that they use to not include any external dependencies, which is, I think, pretty common in some of these Linux variants. Have I reversed the iOS mem cache and IDA kernel cache? No, I haven't actually. Ran 8833. Have you done iOS reversing in IDA before? Hey, Alzano Good. How's it going? I don't know how to pronounce that. What do you think of Ghidra? I do like Ghidra. I'll probably do some Ghidra streams in the future. I'm just not very good at using it. I know you can get like IDA key mappings for Ghidra, etc., but it's just something that I need to spend more time on. I've been, we have the training that I do, the Invoke RE training stuff. So we have like a Binja course and an IDA course, And I don't really want to stretch myself too thin with learning a third RE platform, just because there are, a bunch of different nuances to their APIs and et cetera, et cetera. And then I think with Ghidra, you'd have to basically use Java or their Jython interface, et cetera, et cetera. So Tony gave this to me. It's called Avalon, from what I've seen. It has some references to the Avalon game in it, so I can upload this for you all if you're interested. Why don't I do that really quick? Do I need to log into Bazaar to upload it? Okay, cool. Yeah, let me do that. Upload. I have to log in. Poor Buster, do you have a Malshare account? Because I can just upload it there. To Go file. Okay, yeah, sure. Hey Gooski, how's it going? Thanks for joining. Okay, hopefully the Go file thing works. I've never used that service before, but Peronos Chino. Hello, my dudes. I'm new to RE. I'm looking for some NASM assembly resources. I don't know if off the top of my head I have NASM stuff, but like, are you just looking to write assembly and then reverse it? Use it as stagers, yeah. Okay, so asmtutor.com, is it good? It just has examples. Oh, cool. Okay, well, yeah, you can definitely check this out. I haven't used this before, but looks like there's like sockets and a calculate string length subroutines. So this looks pretty good. FizzBuzz, you can pass some interviews with this ASM Tutor website. Is there an ASM Tutor for ARM? Yeah, that's a good question. Let's continue with the sample. All right. Yeah, that sounds good to me. Okay, so we're in the start function. So I let Lumina run. So I did pull all here. This basically just tries to use Flirt with the Lumina server to identify any known functions. The reason I did that was just because there's all these statically linked there's all these statically linked libraries that are included in this, and I didn't want to spend the whole stream just fumbling around the syscalls and then reversing things that were just like stir copy, string case compare, encode dotted, inet, pton for whatever, like all these different functions that we could have reversed those manually, but I found that if we have the tools at our disposal, something like this, then we could just start from there. And then in this main function here, uClib main, this is actually a part of, so if we were to just search this, it's a part of this uClib LM32 library. And this is a small C library for Linux, and then it's commonly used for embedded Linux systems. So what that tells you is this is probably being used for maybe embedded IoT devices, maybe just to try and make it as generic enough as possible in order to interface with as many Linux and Unix variants as possible. It is a 64-bit L file though, so I should, mention that because that might limit the amount of things it can run on. For ARM, I like the Blue Fox book. Yeah, me too. It's actually on the end right there, which you can see there's a bookmark in it because I'm currently reading it. Would love to take some of one of her trains. Yeah, for sure. Use signatures or manual, maybe IoT malware, just like Mariah. Okay. Yeah, so uClib C library. The U stands for micro, I guess. And then basically with the Lumina server, we were able to recover a bunch of associated functions that were likely associated with this uClibc library. So I can get out of, the F5 view here if we want, just to look at the raw assembly. Oh man, I am not used to using IDA. I've been using Binja for too long. And then there also, I should make mention that there is the init proc and term functions, but I think these are just standard boilerplate like ctort stuff. So I don't really think we need to look at those directly. Okay, so if we look at the assembly here, I would put them side by side, but maybe we'll leave that for now. And we could see at just because this is pretty blown up and super high resolution, so it is kind of hard to look at them both side by side. But if we go back here to, so uClibc main is called, and then there is functions that are set as arguments here. So this sub 404E70, if I navigate there, then we can see a few things right off the bat. So we have this sub 409080 function. If I navigate there, this is just a really basic mem set with zeroing out the given buffer. So we have a given length here, which I is being tested is equal to, and then the argument is essentially being zeroed out through this loop. So we can just do like MW memset. It's probably standard. We don't know what this is yet, but I'm just going to put 32 byte buff, and then we'll just say 256 buff. And we can see that 256 byte buffer is already used down here. And then, so kind of going back to my university days of operating systems with Linux and Unix, I know that these are fairly file centric. So having something like proc self exe, if I were to search this, then this would essentially return the executing file path for a given binary if it was to be accessed. And this Brave thing mentions this. It's a symbolic link to the Linux procfs file system that points to the executable file running the process. So it's basically a symlink at runtime that the binary can access. And then you probably guessed it. Let's see here. If we were to check out, maybe it's not super obvious what this function is doing, but we have a sysreadlink. So this is already marked up, but let me sync with the disassembly view here. So we have too many IDA views open. Hold on. Let's sync this with our decompilation view. And then we can see here that this is actually a syscall being performed. So let's get out of graph view. It's annoying. And this is the Hex-59 syscall that is a sysreadlink. So helpfully, IDA's already marked this up for us. So pretty easy. Lol, every AV calls Linux malware Mirai. Yeah, for sure. Maybe due to rules. I too haven't analyzed any other Linux samples other than Mirai for now. Yeah. Okay, so let's just say this is, we'll just say MW sys readlink. So readlink is being used, I believe, because this is in fact reading the link to the executable that I mentioned earlier. So the symbolic link, the symlink. So that's why readlink is used. But let me actually just double check this. I'm gonna have to search stuff because I just don't want to be spouting nonsense. Yeah, read the value of a symbolic link. So that's exactly what that's doing. So, and then this is reading up to 255 bytes. And then I don't know what this, is this the actual value here? Anyways, let's go back to our main here. Yeah, it looks like it. And then this is probably the return length. So let me just double check that. Buff size. Yeah, places the contents symbolic link path, which has a size of buff size. Null byte to buff. Truncated to the length of buff size and characters. Okay, so then we have the path, the buff size, the buffer, and then the size. So this is going to be the path, the buffer, and buff size, I believe. And then this is just going to be succeeded. And then if we look at so path, buffer, buff size, path, buffer. So this will be process name. And then this is just the last offset within the name. So this is going to be, let's just say end proc name. And then they're just adding a null byte here. Okay. And then if we look at this function, it's passing /proc. Assume this is used in more than one place. Yes, it is. But this looks a little bit more complicated. So we have this SENTL64 function. Again, I'm going to have to search these. So it performs one of the operations described below. The operation is determined by CMD. Okay, so the command in this case is going to be, hopefully we have enums for Linux samples. bfdup. Doesn't look like we do. The file descriptor, the command. Yeah, so that'll be the command there. Let's just say this is the file descriptor. How do you search enums? Yeah, so usually you just hit M, but it really depends on whether or not IDA has them embedded or not. But let me see if I can bring up type libraries here. Yeah, so we have GNU, C++ for Linux. So I'd expect the file descriptor stuff to be in there, but maybe. So they've adjusted the type system in IDA a little bit so that it has this new type libraries and let's see here, local types area. So I think they merged some stuff if I recall correctly, but if I want to, basically these are loaded type libraries. And then if I go to the type library for this particular GNU Linux 64, then we can just see a whole bunch of defined types. So for example, those syscalls that we were looking at earlier that we found are mapped here. So that's why those are being labeled properly by IDA, is because they map to an actual enum. But yeah, it looks like we don't have this particular one, but that's okay. For manipulating the file descriptor, we probably don't need to look at this too closely, but this is getting the fs stat. So this will get the file status. So let's just say, and then 2 arguments. So we'll have, do we have the stat buffer? Okay. Yeah, so also in IDA, you can just hover over the given function. So then you have the file descriptor and the stat buffer. So I'll say fd stat buff, and then this is being moved here. So the stat buff is what file type, or what type of, is it just an unsigned integer? Probably not. Oh, it is. Oh, struct stat. Okay, so, sorry, that's what I wanted. So if we have the stat pointer here, then this is going to take a stat pointer, I think. And then we can see that this struct A2 is basically being initialized to all the stat variables. And it looks like they are in order, so I can probably just say this is also a stat variable. So that looks good. And then we want to mark these up as the same type of struct. Okay. And then if I go back to where this was used, then now we know that this, oh wait, and then the second argument is going to be that too, right? Stat buff. Then now we know this second argument is a file stat buffer. And if we look at where this is used, or sorry, we want the second argument. So this guy. Oh, it's just checking if it's greater than 0. So it's actually not using the struct in that instance. And then it's just manipulating the file descriptor. Again, we don't know what enum that is, but that's okay for now. And then we get a allocation here where we have the file descriptor. So we can make a new struct type. Will this be the unsigned integer? Let's see here. If we, so the file control, again, we don't know what type of file descriptor this is, but it's probably filling out this struct, which is annoying. Let me just see if I can find it. uClibc might have the mappings. Int fd is this. I have to log in to search the symbol. That's so annoying. Okay, fsetfl. That's probably why we couldn't find it earlier. Oh, fsetfd. Okay, so the fsetfd. Okay, so the stat buffer. We want the man page for this guy. It probably actually would have been faster to do this on Linux because then I could just looked up the man pages locally, but whatever. Okay, fset fd. I think this is just set file descriptor, but I just don't know what this is going to provide in return. File descriptor flag, set the file descriptor flags to the value of the argument. Okay. Okay, let's just say, okay, let's just say this is a custom struct because it's going to be opening a given file, right? Because we had this is going to be a file path / proc, the file descriptor for path, something like that. And then let's see what this does. A connection between the file and the file descriptor, create an open file description that refers to a file in file descriptor. The path argument points to the path name. So what do we have here for arguments? Okay, so we have a variable number of arguments here. So O flag, there's a whole bunch. All right, so let's just say this is acquiring the file descriptor, checking if it exists. It allocates this struct. So let's create a new struct here. And then we'll say this is the file descriptor. And then it's just initializing a bunch of values here. So I don't know if we want to fully manually reverse these because it's probably associated with whatever the statically linked code is. Let's see here. Okay, and then it's returning the struct. So at least we know the first offset is the file descriptor. Let's just put read path for now. Thanks for linking that again, XeroxSec. Okay, and then this is going to be, so we created that struct, this unknown struct right now, but what type is this? Struct v12. So we'll just make this also a struct v12. So if we look at our disassembly view here, let's see. I just want to see if the relative stack variable is whatever. Okay, read path. So if I double click on this guy, man, I haven't used ident forever. I forget all these different hotkeys. Let's see here. And it might actually be different with the Linux elf view as well. Okay, let's just assume that's fine for now. Because if I change this to struct 12, okay, yeah, that doesn't even work. So, okay, so let's say proc path. And then this is probably going to be enumerating the proc path. Let's see here. I really wish I had these particular functions marked up. That'd be super helpful, but let's see, sysdent64. This is not a function. Look at readdir. Get directory entries. Okay, so this is going to get the directory entries for a given path, at least based on that syscall. And then the path is the first argument, correct? The file descriptor, yes. And then let's see here, what else we got? Okay, so Linux dir entry is the second argument. Let's do this. Missing declared semicolon. Oh, it's already marked as a dir entry 64 anyways. Okay. And then let's see here, we got glseek, and then this is probably, okay, so let's just say this enumerates directories, which we have marked already. And then what are they providing as parameters again? Let's see here. Okay. And then this is looking for various control characters. So this might be, okay, it's accessing this. I don't know what the 10 provides. Okay, I'm not 100% sure, but let's just say process dir entry. Let's see where else this is called. It's only called as /proc. Yeah, it looks like it. Okay. There's some C2 stuff, spoiler alert. And then it looks like it's just getting, this is probably vsprintf, yeah. So for this, basically it's just a vsprintf wrapper. So let's, and then let's see if that automatically recovers the arguments. It did not. But here we have, I believe this would be the PID that it's after. And then we're gonna read a given PID. Do you usually reverse all the functions from top to bottom? Not always. I just am this case to get like kind of a lay of the land, but more often than not, like if we really wanted to reverse this super fast, which if you guys are bored, we could probably do it. It's just pivoting off of the strings. But just if we start seeing like where these strings are used, and then like we did see that this was vsprintf, for example, and then this wasn't readlink, then it, we'd have to reverse those anyways. So it could just be a good starting mechanism for this. So I don't know why this is marked as a LOC. Okay, so it's just jumping to exit. But why would it be calling exit? 409, 4C0. Okay, maybe I will put these side by side. Let's see here. And if this is hard to see because of chat, let me know. 4C0. Okay, so it's just calling the start of this function. I don't know why it's just optimizing this out. That's what it looks like. So sysconf, let's see, get configuration information at runtime, and then with a given name. So 84 would be what? I'm just going to search this too. See advisory info. So the configuration constant that can be queried using sysconf function in Linux. Advisory locks and process. Okay. So what was the name for that? It's sc advisory info. It doesn't look like that's there. It could just be the AI summary not being right, but that's okay. This is called over here. Okay, so let's get back to where we were. Okay, so this is going to be again, our process name and proc name with a given PID. And then that function's called 4094C0, which is the beginning of this basic block. So if it's going to XOR, compare it with 0. Okay, yeah, so these aren't fully disassembled, which may be a problem. Maybe this is anti-analysis stuff, but because this isn't a valid opcode, right? Maybe I'm tripping. Yeah, I don't think so. It's just to find bytes. So I don't know if this will actually be a valid call, or if it could just be IDA's disassembler not working, but and it gets dir entries. Okay, so I think it's just looking for these particular file paths. So like user bin sh, which would be a hidden, let's see here, .sh does not exist. Is a recognized system path. It may be a typo. Okay, so they just might be looking for something in particular. Yeah, I don't know why it's .sh, which means it's a hidden file, but that's a good question. Okay, and then, okay, if not, end entries. I think this is just looking for whether or not the process already exists in memory, because it's iterating through each PID, because it's getting get PID. So if it's this entry, then it breaks. Otherwise, it iterates over the directory entries, and then it's getting this from the proc path. So I think it's just making sure that it's not running already. And then if it is, then it will exit, which makes sense. I don't know what this s.sh is, but it might be something to do with persistence on their side, which might, like this might be an indication that the malware's already infected this machine as well. But we can check that out later. Like, is this string used multiple times? It is. So let's see what those in a bunch of different spots. Okay, this is just the, okay, while access. Okay, I don't want to jump around too much, so let's assume that's probably the case. And then we just get further entries on each iteration until there are no more possible iterations. And then it exits this while loop with a break. So not dir entries, break. Okay. And then if we reach the end, then we have this function call, which we can check out here. Again, more libraries that we don't have access to, but that's okay. By the way, if anybody has tips for like things to look for, or anything that should be, super obvious to you, if you have experience with a lot of Linux malware, just let me know, because again, it's not super my wheelhouse. But okay, so this is going to, again, we have another open operation here. Hey Psyched, how's it going? Thanks for joining. Okay, open file. And then I don't know what these two are used for, but let's see here. Okay, so let's check out open again. And then we have, okay, so flags and mode. So this will be, what do the flags look like here? O underscore. Okay, so since these are multiple flags, it might not pick this up automatically. Let's just call this flags and mode. New to malware stuff. Saw that you do this analysis stuff. Hoping to learn something here. Awesome. Yeah, thanks for joining. I really appreciate it. V9. Yeah, so this is mode. And then this is the file descriptor again. Okay. Not entirely sure what these guys are used for, but basically it's just opening and returning the file descriptor. These might be, like, this might all be exception handling stuff. So let's see here. Let's just have that for now. Maybe a quick check could be if the malware is disabling SE Linux. Oh, cool. Yeah, that's good. Good shout, Goof. So if I go to our strings here, I'm just going to enable. Yeah, it looks like there's all the types that we need here. I don't think there will be wide Pascal strings in the sample, so that's good. And then if I search SE Linux, it doesn't look like there's any SE Linux mentioned here. Disable, unless they're doing it via like a syscaller API. Okay, so instance lock, and if it's greater than 0, then we have the instance lock here. Maybe, yeah, that's fine. FD. Okay, cool. So now it's reading a bunch of stuff. So if we, okay, so this is going to be a FN control wrapper, or FCN control wrapper, and then it's getting 6, which is going to be CL get FD, maybe. Sorry, I just need to find this guy again. CL get. I think this is controlling the file descriptor, so it's probably not that guy. Let's see, F underscore set LK, maybe set link. Yeah. Okay. So this is going to be setting the link for this instance file descriptor to what? These are probably like symlink. So see, it's making this D word here of 1001, because I assume this is bytes. Yeah, it's keyword. Cool. So F control 64. Let me just see what this does. Acquire lock and release lock. Okay, so it's just acquiring a lock to the file. So if it can acquire a lock, then it passes this here and then it closes it. So nothing amazing. Or let's just call it a close. Let's just say it's close because it's a close wrapper. Again, it reads self again, and then it's reusing this variable, which is kind of annoying, but okay. And then this is going to be a string array of temp sysd and var run sysd. Let's just call this sysd strings, and then let's see. I'm just going to search this real quick because it's a pretty unique string, so maybe something will come up. Volatile directly. Okay. Often same link to run systemd for the init system. Okay, so that's good to know. So it's probably init related. Let's see here. So this is reuse, which is annoying. So let's just call this path instead of proc path. And then where are they? Okay, they're just opening a handle to those sysd files. I'm just going to call this FD because again, this is also reused. If anybody knows why they'd be like reopening this, maybe it's just crappy malware, but why they'd keep reopening this file descriptor, I'd be interested. So here, let's just say, okay, so this is basically iterating through both of those files. And then let's see what this does. Read. This is a read wrapper. So this is kind of why I want to do like all this stuff up front. I know it's kind of boring, but once we get all of these wrappers done, then it'll just be like 30 times easier to read. So, so for example, now we know that, I don't know why we don't have read. Okay, read from file descriptor. And then we're going to be count file descriptor buff. Count fd buff. And then now when I define that function, then I can just hover over it like this and then see that we have count fd buff. But that doesn't actually make sense because this length is being provided. So this might not be the correct read here. Sys, let's see, count fd buff, whatever. This is going to be the length. So let's say length, and then 14 is what? Okay, so the first parameter is the file, or is the file descriptor. So then this is going to be buff. Okay, so this will be fd, and then this is going to be our buff. And then this guy's passed to this function, write buff. This is going to be the amount read probably. And then we're going to have the file descriptor as the first parameter here. Okay, so let's figure out what this buff is. So I think it's reading from the self-exe. Okay, wait, maybe I should rename these again. So there's going to be self-exe. And then instead of path, we actually want this to be the sysd. And then this is going to be the sysd fd. And then this is going to be self-exe. Okay, so I think it's just writing the, okay, cool, yeah. So it's just writing the process name into these files here. Okay, so I'm just gonna add a comment here, written file name, or written process name rather. So nothing groundbreaking, but these would be good IOCs for this particular malware, since these hidden files would be present on a given system that's infected with it. And if you looked at it and there's a process name, that you could say, okay, it's probably this malware, right? Okay, so let's see what else we got here. Then those are closed. Then we have a big function. So this might also be exception related. Yeah, I just drank a bunch of coffee, so I'm just gonna run to the washroom real quick, but really appreciate you all joining. Again, I do malware analysis training and a bunch of other stuff. If you're interested, if you want to check out this stuff, or thanks for joining, really appreciate it. Yeah, I'm definitely going to do more Linux stuff, maybe some Mac OS stuff in the future. So really appreciate you coming and hanging out. Kruth HK, hey there, I'm also very new here. I have one silly question. Sorry if it's not a appropriate place for it. Does the IMBT course have prerequisites for what you should know? So actually I can go to the FAQ page, which goes over that stuff. And it's definitely a good place to ask. So basically I just say that students should have some prior experience with Microsoft Windows and operating system internals, like as a whole, like, so you know what a process is, you know what a file is, a directory is, etc., and a high level understanding of network protocols and OSI layers. So if you've done like any academia stuff, or if you understand like what an IP address is, what a TCP socket is, what a UDP socket is, etc., then that's definitely a huge plus. And then if you've done any like C and C++ and have a basic understanding of command line interfaces, that's also a huge plus. But if you have like any technical background, you could probably do the course, Kruth. But yeah, speaking of which, I'm just going to run a quick ad for our IBT courses and then run to the washroom, and then we'll keep on with this Linux stuff. Okay, I'm actually a network threat hunter by day. I do need to do some C though. Yeah, no problem. Really appreciate you joining the stream, but yeah, I'll be right back. Hey everyone, my name is Will Reynolds, and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right, let's continue. Kruth, HK, I should mention that there are a bunch of, I think you're already in the Discord, but there is a bunch of folks who do threat hunting stuff. So you can also ask them questions if you want to on there. So, okay, so let's get back to the sample and see what else we can find. So this, let's see here. This looks pretty complicated with a big buffer with a function pointer. I just want to see what this could be. Fork. Okay, so let's say MW fork and a bunch of other stuff. These might be like boilerplate runtime objects. And by objects, I mean structs, because this is not C++. I've been doing so much C++ stuff lately, which is why I had that on the brain. Okay, so this is freeing this global. Yeah, this definitely looks like runtime library stuff, which would be this guy here, the uClibc library. So the other approach that I would take with something like this as well, I won't do this today just because it's pretty boring to watch, is compiling and linking that library. Oh, sweet. Thanks for the raid, Lucas Develops. How's it going? Thanks everybody for joining. So let's check out Lucas Develops. If I can type. What are we up to today? Lucas. Ooh, we're getting a McDonald's ad. That's cool. Let's make stuff. I'm a Finn Swede, but do streams and stuff in English. Nice. Debug physics and Zig and Vulkan. Nice, that's awesome. I've heard good things about Zig. I haven't used it yet, but I heard it's pretty good if you're coming from something like C. Is that accurate? Hot reloading, cool. No hidden control flow, no hidden memory allocations. Yeah, incrementally improved your C++ Zig code base. That's cool. Yeah, I really appreciate the raid and for coming and hanging out. I don't know if you have to take off, but don't worry if you have to. Okay, so sys set SID is then called. Can you explain hot reloading to me? Okay, so creates a new session. If the calling process is not a process group leader, the calling process is the leader of the new session. The calling process also becomes the process group leader. Okay, whatever. So this would be set process group leader. And then these globals, which are probably initialize in that other function. Let's see here. Mem copy. Oh, these are initialized in main. So let's just say main init globals k worker execcl. I'm back. Progress. Working on it. Port buster. Let's see here. So we have a while loop. So is this just getting the string length? Maybe. I assume this is probably looking for arguments, but let's see what execcl does. Man page. Execute a file. Okay, so sysd and then kworker. So it's just re-executing this file with kworker and then exiting. So executing. So I was wrong earlier when I said that this sysd was the process name. It's actually the process data itself, I believe. And by that, I mean the file data itself. So let's say self copy. And then it does sysunlink, which those of you who are familiar will delete the name and the file it refers to. So this is a delete. A quick explanation, I need to go, but it is basically compiling part of your program into a dynamic library and then seeing the changes in your program without needing to restart. Okay, awesome. Yeah, that's super useful, especially in a compiled programming language, because like I'm sure most of you are aware, debugging a compiled language can be difficult because you're constantly having to recompile the program and then re-execute it. So that's cool, especially when writing plugins for like these reverse engineering suites that are also compiled. So that sounds super useful. And it probably is useful for malware development. I don't know if you've done any of that, but okay, so we have our main initialized globals that are iterated through. Okay, so let's figure out what the k worker parameter will do. I assume there's going to be multiple references to this, maybe not. But let's see if that affects our entry point here. Okay, let's call this malware main. And that might be, let's see here. Okay, this looks like a regular string copy. Let's call that that. It's used everywhere. Let's see, what is this guy here? Okay, this is probably another string copy. So our dest source initializes these two counters, and then let's see what else we got here. I assume this is dest, right? Or temp. Yeah, so this is just another string copy. Okay, this might be a stern copy. Okay, so then this is going to be Paulo next 2025. I don't know whether that string has anything to do with this, but it might just be a campaign identifier or something in this malware. Paulo Banchero was an NBA player. Okay, so probably nothing, but the 2025 means this was probably compiled in 2025. Orlando Magic. Maybe this person who wrote this is a basketball fan. Let's see, is this actually used anywhere? Try Google. Yeah, nothing with quotes. Yeah, I don't see anything. That's okay. Oh yeah, I just wanted to see where this was used. So if we look at, this is used here. Ooh, cool, I think it's a key. So, okay, who can tell me what encryption algorithm this is? Quiz time. Anybody? There's kind of two right answers. So this is probably Salsa 20. If any of you have done any work with these encryption algorithms. Yeah, it could be Cha-Cha or Salsa. Let me see if we can figure that out. Let's see here. Library hard-coded Sigma. Yeah, it's probably Salsa. Just because I don't know if that little standard library has a Salsa implementation, but based on these constants and results, let's see. Yeah. So these are part of, let's see, the nonce initialize, the initial state. So this is basically making up so it's a stream cipher, right? And then the initial state is made up of these strings. So it's super easy to spot in malware because you can just look for these strings essentially for both IG. Oh, let me check this out. Cha-Cha 20. Yeah. Let's see, diffusion, performance, structure. So a 4x4 matrix, but internal rotation constants. So I don't know how hard it would be for us to determine that based on this algorithm, but let's say cha-cha or salsa. We can probably encrypt and decrypt stuff to see. Okay. So it's going to be initializing with this key, and then we don't know the exact implementation of this, but it's probably going to be, let's see here. Okay, so we're copying, so this is a mem copy. We're copying the 113 bytes. I assume that's the length, right? Let's see. Yeah. And then on each iteration, I is incremented. So then we have, let's see here. So we have the source A2 and then into A1. So dest. Okay. So it's copying 113 bytes from this, whatever this is. And it does that. Oh, let's see. Hold on. Why is this just being initialized to the number 1? I assume that's not it, but okay. So we have a socket creation. So it looks like this is probably the C2 stuff. So maybe this is a session key that they're using for encrypting the communications. We can probably confirm that. Let's see. Is this used? Okay, so it's always used in this reference to the algorithm. And then this is probably the actual encryption piece. Maybe. This could be the command handler. Is that always called after that? This destination is set here. What is this? Send to. Nice. Yeah, so it's definitely a session key. Ooh, I did not mean to do that. Is that one word? Yeah. And then we have our send to here. I gave that section to Mr. AI and it says cha-cha 20. Oh, cool. Nice. Yeah, thanks for doing that. I didn't want to use AI too much, just so it's not like me vibe reversing this thing in front of you all. Okay, so this is probably our socket, I would assume. Yep, our socket, and then socket, and then and then we can get the protocol from our socket here. So if I get the man page, then we have the domain type and protocol. The domain being in this case the communication domain, not the not a actual domain name. So in this case, we're going to have AF. So AFINet, unsurprisingly, it's going to be IPv4. And then 1 is going to be socket stream probably. And then what's the last one? The protocol, which is probably going to be TCP. Let's see here. Maybe not. Let me just double check this. The protocol specifies a specific protocol used by the socket. Normally, a single protocol exists, in which, a single protocol exists to support a particular socket type within a given protocol family, in which case the protocol can be specified as 0. Okay, so I guess it's unspecified. Is that right? If anybody thinks that's not right, let me know. Okay, so here's some data. So if we look at this, these side by side, we have, so this is probably together. So I'll just say int 32, so that they're part of the same data. Okay, and then we're setting socket options. So let's mark these up. Sorry, I know this is kind of boring, but it's just so we understand exactly what protocol is being used. But if we were to look at the strings again, you can see here that, let's see, we have a HTTP header, like user agent. So they're just going to be using TCP, basically. But if we wanted to look at this, set sock option, look at this man page, let's see here, set, okay, so the socket, the level, specifies the protocol level at which the option resides. Okay, so not super important. What else is there? The option name argument. So which one's that? Let's see. Ooh, man. A single option to set. Okay, so let's just leave that for now. And then what's this global function? It's this guy. So is this just going to be converting the IP probably? Okay, so this looks like a decoding algorithm of some sort. And then we get the result that calls inet A to N. So if we look at that, this just converts the given input to an in address structure, I believe. So I think this was one of the recovered functions. So we're just going to be getting a in address structure out. So we'll say in address structure like this. Maybe not. Oh, did I do it in all caps? And then we're getting the source address. Like if I click on the, let's see here. Okay, yeah, so it's just getting the IPv4 address in network byte order. I just wanted to double confirm that. Okay, and then this is called like a whole bunch of times. Okay, so this is actually going to be our IP data, not data 4. Did you look at in a sub 401 or 404190? Let me see. Let me just finish this real quick and I'll check that out. This looks like it's an IP address though. And then it's being manipulated in this loop. But I'll double confirm that. Yeah, I see anti-analysis too. Or I saw it earlier. Not right now. We can take a look at some of that if folks are interested. So let's see, malware, get IPv4. Okay. I don't know if this is actually a decoding algorithm. This might be, because this is dead beef, but then it is doing this XOR like mod stuff. So it does look like it's decoding a given value with a seed. So this will be seed. But yeah, need to double confirm what that's doing and what it's used for. But if we look at, can make more room here. Don't know where this keyword is initialized. Doesn't look like it's anywhere obvious. But yeah, let's look at the anti-analysis stuff because that's a little bit more fun than some of this, even though this is probably one of the most important functions because this is, oh yeah, I just want to mark up the global. This is probably decoding an IP address. Set decode IPv4 func global or something. Yeah, it's an encryption key for the C2 columns, it looks like. But yeah, keep the, if you can reverse this with me, that'd be sweet. So we can divide and conquer. Okay, so yeah, this is IP data. So we could, let me see, why didn't that work earlier? Because this is adjacent. Does this need to be a keyword? Oh, so this will be like that. And then this will be IP data address. See, because then the starting offset is assigned this 9307, and then it gets the second half of that part. And then if we go into the, let's see here, get IPv4, that's going to be the location that it's assigned. But yeah, let's continue on. Why is this invalid now? Okay, maybe I won't do that. All right. Okay, so this is like key initialized, unknown. Okay, update, invalid byte offset, or this is just exit, I think. And this might be the exit reason. So if we saw this earlier, this was like user bin sh, because I don't think there's a, and then the process name. So I feel like this is like an exit reason. And then this is like a, I know we saw those file descriptor handles being opened earlier, but I think this might have been basically a lock file to say that this was already running. So let's just say exit with reason. And then if we look at the other ones here, okay, then they're just like similar. Okay, so let's keep going. Let's look at the anti-analysis, which would be important if we were dynamically analyzing this, which we're not, so it's not super important, but so they're going to be reading the proc path again, iterating over the entries. Okay, and then they look for a bunch of common analysis tools. So we have string and string fgetS from the given directory with the command line. That's pretty cool. Standard IO open. Okay, so I'll put this in the notes. Any like confirm stuff, I just put in the notes. So this would just be basically looking for a dynamic analysis environment. So curl, busybox, GDB, strace, valgrind. Like strace and valgrind are really useful for this stuff. Ethereal I've never heard of, but maybe it's for debugging. If anybody else knows, Linux protocol analyzer sniffer for Linux. Cool. You're vibe reversing? Don't. It's cheating. What are you using, IDA? Or what are you using? We can probably mark this up and then get AI to reverse it next stream or something. Dogbolt copy paste. Nice. That's one way to do it. You should just get an RE suite and then like you can get a Ghidra MCP server and you can basically do it for free if you already have a, well, not free, but if you have an Opus or a subscription already to Anthropic, then you can just use it that way. Okay, so command line, file descriptor, command line. Right, we already know this is what this is for, but I just mark things up. Oh, and then it kills them. That's funny. Or is it breaking out of the loop? No, kills -9s them. Analysis, or probably PID, right? We can double confirm that here. Yes. Get PID from entry. Entry. True. I'm more of the simple way. Copy paste. Tell me what it is, or I'll shut you down. Yeah. I feel like those MCPs take too many tokens. Yeah, for sure. I think there's probably more efficient ways that folks can do it, but probably hasn't been figured out yet. Okay, so let's say entry, and then is this, what is this? I think this is exception related too. I should probably figure out what these functions are, but okay. So let's say MW kill analysis tools, and then this function looks big. Okay, CPU info, and then it reads it. Do you look at the .sh persistence? No, but we should do that because that's what I was talking about earlier, but didn't reverse fully. But let me just do this real quick because okay, yeah, cool. So this is more anti-analysis stuff. So it looks at proc CPU info, then looks for virtual environments or VMs. And then it looks for these virtual machines. So VMware, I'll just say VMware VirtualBox. What's this? VM. KVM. Why is it not working? Because it can't, this byte can't have a name. Why not? I feel like I keep messing this up. Okay, VirtualBox. Okay, if I can just change, it is a char array, so why isn't it picking up? Whatever. Okay, so what's this one? Probably QEMU. Yeah, QEMU. VMware, we got that one. Let's see, VirtualBox. This is KVM. Okay. So the reason they do this, for those of you who are not aware, is that if they are running within a sandbox that is, KVM, any of these virtual machine based, then they'll be able to detect it. Hyper-V. Looking into the dynamic C2 domain, they pasted into the sample, but it's offline. I'll see if it's anywhere on URL scan. Yeah, that sounds good. Thanks for the help. Okay, they look for temp sandbox, Docker environment. They look for these two. I don't know what VZ and BC are, but maybe those are common sandboxes too. /proc again. Get directory entries. Let's see here. /com. I don't know what that's for. Open. Let's see. I know, but what's the path for? Say /com path. Refers to the special file in the proc file system. That's the command name. Okay, and then this is basically looking for box service. And then what else? Yeah, this is the V. Oh, I think I know what I was messing up earlier. So if I do /com to find box service, like this is good. Obviously there's box client. Obviously there's utilities that you can use to enumerate this virtual machine detection, but actually knowing what is being detected in the wild and then hardening your sandbox against it is really good. VBox client. Yes, be VBox service, VBox client. So like if you have a Linux box that's running on VirtualBox, it's probably going to have these command line utilities running, right? For interoperability with the virtual machine. Oh, let's see, hold on. You got auto-modded for something. I like how they're concatenating strings to get rid of the static analysis. Oh. It's because you put static ANAL, and then that's why it flagged it. That's so stupid. Okay, tools SD, yeah, okay. So we don't really have to like get all of these. Oh, so this is VM tools SD, so this is looking for VMware. Whatever, I'll just finish this because I started. VMware VMX. What's this one? VMware, same thing. MUGA, maybe EMUGA or something. Let's see, it'll be here. QEMUGA. What's this one? PRL tools. I don't know what that is. Do you guys? All right, cool. So yeah, we got all those. And then I assume it kills itself if it sees this. Check for VM environment. Let's see, what does it do here? And this is probably more anti-analysis. Pacer PID. Okay, so we would have gotten here eventually before getting to the meat and potatoes like C2 stuff. But it was kind of good that we jumped ahead because that probably would have taken a little bit. Hey, fake Siva. How's it going? Okay, so what's this one doing? So pacer PID, tracer PID. With what's this being done with? Proc self status. This is all stuff that I wasn't really aware of, so that's cool. And then what else? Is that it? I think this is just getting the, okay, cool. Yeah, so that makes a lot more sense. Yeah, it's anti-debug, yeah. Anti-debug tracer PID. This is called multiple times. Dang. Probably the different entry points, maybe. All right, look at all our cool markups now. Okay, so let's keep going. I don't know what this is. Let's see here. This is a big old function. Probably more crypto stuff, maybe. And by crypto, I mean encryption, not cryptocurrency. Because these are all encoded bytes. Let's see here. Ooh, I want to know what this is now. While not equals to 62, result. Okay, let's see here. V0. Encoded data. Okay, so are these structs in memory? Should we mark these up? Probably. But I guess let's see what these are used for first. So we can go to this global. It's not obvious. Okay, maybe let's mark up these globals and then we'll figure it out. So, like maybe I can, let's see here, because these pointers are just gonna be side by side. So encoded data 5. Ooh, mama. Okay, there's a lot of these. Do you think this is creating a key or something? What's the address for that one? Here, yeah, I'll link it. And by link it, I mean copy paste it. I just don't know where, like maybe this result is going to be the start pointer. Hopefully. So I don't have to like figure out what else. Because like each one of these global variables are going to be referenced individually. So let's see. And I might be reversing just some encryption algorithm, which would be annoying. But I did run kappa against this too to see if there's anything obvious, and there wasn't anything super obvious. So, okay, there's a lot of stuff in here. Maybe we won't finish this today. I think that's part of the functions for the initial communication with the STU. Okay, cool. Is this just all like junk? /proc. Okay, so more check if running cross-referenced in sub 404E70. Yeah, that's where I just was, I think, which I renamed, right? Oh no, 403. Okay, let's see, fork PID. Okay, so and then let's see this one. This is probably making use of that initialized global data. So we should probably reverse this. Okay, it gets the time, parent PID, clock, or well, what does clock return? The processor time, and then XORs those together. Wait, XOR PBID time man page, time a simple command, time start, get. All right, let's see what this is used for. Okay, so connect. This might be like a challenge response or something. Get socket name. What's returned in result here? v3 initiated connection socket, and then yeah, socket file descriptor address. This will be the address. Okay, so let's figure out what address this is. So this will be a D word. Set the type, and then 8.8. Is this just localhost? Let's see, to IPv4 converter. Convert. So the first half will be this. I don't know if it'll take it in hex, but we'll see. 0. Is that right? I don't think so. Because 80, let's see here. So 32, 53. Can you figure this out, poor Buster? What IP address this is? Okay, and then the address, because it's just connecting, it's just getting the socket name and then closing the socket. So I don't think this is super important, but what's the address of the function here? This one. I think it's just localhost, and I can't convert it. Like 127, because it'll be 4 octets for each number. I just need to remember the IP conversion, and then, but 08 wouldn't be, yeah, maybe it's not localhost, but I think this is just a connection test. See, then it's getting the inet aton here. Oh, more encoding stuff. Yeah, this is definitely harder than I thought it was going to be. Because if we look at the strings, let's see, where's this called? Okay, so I'm pretty sure this is a command handler because, let's see here, kill, this is the argument. I think this is passed from the C2 after that cha-cha call. Yeah, so handle command, and then this is going to be our matrix. Oh, and, or wait, no, this is going to be our decrypted data. 14 is going to be our what? Okay, recv from. So this is the received data. Command dispatcher, yeah. 404190. Is that what is this it? I wish IDA would have the, yeah. Okay, cool. So we're in agreement here. This is good. Received data. And then decrypted data. I don't know why it provides, maybe it reuses this buffer to write the response, maybe. Command and, yeah, cool. All right. Okay, then we have a bunch of utilities. So, cool, curl update, we have a bunch of stuff. The sample's pretty cool, but I do appreciate you helping me. I like that you're just reversing with Godbolt too. That's like super funny. If you look for 149.4907, this is a decimal C2 IP. Oh, cool. Where is that? Like I might have converted it, so I don't know if I can just search for that. Whatever, let's just try. Did you figure out what that local IP was? That's dealing with the 404E70. That's where I am, I think. Oh, no, not. In main. Yo, Invoke. see you're on a roll. I had one question about IDA. Is it possible to use IDA in a completely offline manner? I don't know if you can now. I think it needs to do a license check when you start it, but that's a good question. Testing DDoS function. It was by, okay. And we've used about IDA free versus IDA home, so I thought I'd ask. So I don't know if the new versions can be completely used offline. Yeah, this is local. But this is IDA Pro. Nope, they updated their licensing, I think. Okay, so can you use it offline, Congo? But yeah, so I can do a quick blurb. Oh yeah, so while we're talking about this, if you are gonna buy IDA, use this coupon code because you get 50% off. So Invoke 50, you can get 50% off. If we look at their pricing, oh, I need to fix that link. This should not be void 0. I'll do that later. Okay, so there's essential. Oh yeah, there's all these pro expert things. So for personal, so free, you get cloud decompilers. So for the cloud decompilers to work, you would obviously have to be online. And then I think home, you basically get the same thing as free, but you get 2 cloud decompilers and the scripting and the debugger and the multiple supported operating systems. Let's see what else. Okay, so you basically get the debugger and the Python API with home, I think, and more options for the disassemblers instead of x86. So I think that's the biggest difference. But yeah, this one's local, so I installed it locally and then I had to use my license file for it to be active. But I don't know if that's going to be network based. Hopefully that makes sense. But that's a good question. I know the Hex-Rays people, so I can just ask them. Yeah, no problem. Okay, so this IP address, right? Is this what you're talking about? 4 or something? Yeah. But this is decoded, I think. inet2d. Oh, maybe not. What is it dead beefing here? I don't know what this is for. It doesn't look like it's setting it anywhere. Dead beef. Yeah, my context web is not physically available, unfortunately. What do you mean? Web. Encval. And then is this not being used? So was I just tripping earlier? Apparently. Yeah, so I think that in 32 is just directly converted to an IP. Oh, for your virtual machine or something? Oh, or like in your working environment, I guess. That would make sense. Yeah, I just saw that one is offline. There's a list of backup C2s. Yeah, okay. So that's the one I was thinking of. Did you convert this? Low word. Where's that converter? That wasn't really working. IP, what did I say earlier? A decimal to IP converter. And then this. But the lower word will be beforehand, I think. This makes a big difference because it could either be like this, which is this, convert. It could be this IP address, or it could be, let's see, it could be that IP address, or it could be this IP address. I think it's that one, then this, which would be like a drastically different IP, or this one. Okay. Yeah. So basically what I just did, right? 9.3 first. Oh, the first time, okay. All right, sounds good. So let's make that as a comment. Ooh, I don't know what I just did. It's in our notes, but I just want to comment it in the database. Okay, in that case, I can probably figure out that local one. Let's see here. Oh, so was that not right? This one? Did I not convert it correctly? I'm going to trust what you're saying. Actually, it's this. Oh, wait, I just pasted mine. 89.22. Okay, cool. Okay, so let's see here. Check for VM environment. Or wait, no, that wouldn't be it. So if not, and not, then it calls this function. Yeah, I think this is just known for now. Looks like boilerplate. Okay. And then let's look at this. Okay, connection test. So I was just going to do this and then this. That looks like a giant number. Like, is that doesn't look valid to me. Maybe because it's big endian, then it's the opposite. 53? Okay. Anyways, let's keep doing this. Okay, so connection valid. And then I don't know what this is used for, but it's probably like a unique identifier. Let's see, what's this? Okay, I was gonna look at those backup C2s because you mentioned them. In here, might as well get the low-hanging fruit out of the way. Oh yeah, I was gonna look at those other commands too. So, and these are ports, I presume. Super high ports, or maybe that's like packets or something. Packet size. Backup C2, or those could be fake. That's another tactic because these are strings, right? So like people would just use the strings right away, but maybe they're probably backups. Let's say, oh yeah, I started marking these up. Okay, we'll leave that for now. Okay, set. Okay. Okay, so here's another domain. String length, socket, connect to, send, receive from again. Okay, so let's collect all these Pokemons. Where's that domain name? Here we go. So these are probably all valid IOCs. Backup. So this is going to be receiving from there. And then this sets up so recv from, let's see here. I just need the parameters for this. Hey, cuteness overload, sorry. Sorry, how's it going? Cuteness overlord is pretty funny too. Okay, so size socket, buffer, size flags. Okay, this is going to be the socket and size. It looks like this may be wrong again. So we have flags. So 4 is flags, size. Going well, glad I stumbled onto the stream. Don't have much content like this, and don't worry about the username. You're not the first to misread it. Yeah, my day's going well. How's your day going? Thanks for joining, appreciate it. Okay, so this is gonna be the socket. Buff, maybe. Let's see here. I don't know, it's hard to tell. Close. Okay, so this is definitely the socket. I already asked that, didn't I? Okay. So let's say buff, and then we get the length. Sorry, I'm just trying to comb through this to see if there's anything. Okay, realloc. So basically receive from socket, reallocate, and then set identifier. Again, not entirely sure what that's used for. And then let's see, it's probably used down here. Yeah. Okay, so a lot of times there will be these unique identifiers that are used to identify a given system. So that's probably what they're using here, or using the time start and processor time and the parent ID for. And then they're sending that to the command and control server. So it's going to be the identifier. So we can actually convert this to a struct. So I'm going to do that, I can do, let's see, usually you can reset the pointer type, but let's just say identifier plus data. This will be the buff socket. Okay, so this is probably like a check-in domain. Okay, and then what else do we got here? And then we have the proper HTTP data here. So header length. About earlier, those were not backup C2s. They're Tor relays. Ooh, cool. That makes sense. Yeah, I'm glad you checked. So let me say Tor relays. And then the length should be here. Yeah, okay, cool. Okay, so this is where, yeah, okay. Okay, and then we receive within a loop. So V8 I use CI as a alias for like current index. And then we're just going to be incrementing the length of the received data. And then this will be our buffer. The port that you saw in the address is 9050. Yeah, okay, that makes sense. So I wonder if they have an onion address in here somewhere. I didn't check for that. No. Okay, so with the received buffer. Okay, so this, yeah, that's the site where it's supposedly the actual backup CTs. Okay, got it. Nice. Supposedly from who? Did you find more information about this malware? String tokenizer, because it's parsing IP port in that function. It's reading the text file that it gets from that domain. Got it. Yeah, string. Nice. I like how you're figuring this out. Are you actually just using Godbolt? It has a decompiler, right? Dogbolt, not Godbolt. Yeah, sorry, I'm getting my... Yo, this is sick. I forgot about this. Okay, so if anybody else wants to mess around with this, they can... Anger broke. No. Nice, this is dope. Guess the whole binge output. That was fast, too. This is actually how you're looking at this right now. Yeah, so you basically have the same Hex-Rays output that I have. That's sick. Yeah, it is dope. Rex Studio. Look at all these RedTech I've heard of. RevNG I've heard of. Snowman. Yeah, that's really cool. Okay, so get PID from entry. Is that actually all this is doing? Oh no, this is parse data. Rotate right. I wonder if it just keeps them rotated in memory at runtime. That'd be pretty cool. Next token. Yeah, so then it just walks the tokens, and then it's making sure it's less than 3F for whatever reason. And then this is probably the number of tokens, I would assume. Yeah. Num parsed IPs. Okay, so that's a good IOC as well, is that domain. It's being used as that drop for those extra IPs. Might be able to find a sandbox run for this though. Maybe they're not even backup, like maybe we shouldn't call these backup IPs. They're just like the IPs that are gonna be used. Let's go. Decode. Okay, so this isn't being used again. Do you think they're like going to implement this as the obfuscated IP address thing, but they just haven't yet? Because it's just not referenced. Like even in the disassembly, I thought the decompilation was wrong, but they're just setting EDI and then calling that. It's weird. Okay, socket 0. Okay, send receive. Because the sure it's down and not just behind a WAF. Because the HB requests seem pretty specific. Yeah, and they also send that weird thing at the beginning. Like you might have to send that initialization data for it to get it to even respond. Where was that? I don't remember what I named it. This thing. Let's see. Set identifier. Oh my god, this is used everywhere. Did I not mark that perform check-in? Like I think you might have to do this first. Let me send the address at which I was getting 521. Okay. Yeah, anyways. Let's go back to what we... Okay, so I think like, yeah, sets this identifier like a million times. And then encrypts it, and then sends it, and receives the data, and then it checks it again, probably. Okay, so yeah, I think it's like a challenge response, and then it handles it. This thing's pretty complex, actually. Okay, so let's look at the commands. So we've got kill, a given PID, which might be our own. Then we have kill PID again. To kill. I don't know why there's so many of these. Maybe there's like we didn't really look at all the fork functionality, so maybe that's why. Like there might be multiple PIDs that is tracking in memory. And what are these? The command identifiers probably. wget. Okay, so it's just going to try all of these against a given. It's just constructing a command. Update. So mw curl update. So command 2. So let's go to our type libraries, or not type libraries. We want local types. that's somewhere in here. Then we want to add a type, and we'll call this commands. And we'll say commands. Ooh, that's pretty cool. They have, so 2 was update. And then, oh, sorry, 5 is update. So if I hit M here, okay. If it's not equal to 6, and if it's equal to 7, then we do kill 0, which I assume is ourselves. Oh, did you already do all this? I'm not a robot. TCP connect flood. How'd you reverse all these already? Oh, because you used AI, right? That's kind of boring. There's a clanker. He did it for me. Yeah. Did it get case 7? Let's see here. Case 2 parse attack with full options. Okay, maybe this isn't right. He's just copying pasting the dog bolt output into a Claude. I should say they instead of, I don't know if you're, I shouldn't assume your gender. Oh yeah, kill 0. Sorry, I got distracted. Kill 0. Special case. I know, but the kill PID exists. Oh. Okay. So it's sending the signal. So check signal. Can send signal. And then kill 0, 9. I think that might be wrong. And then exit. So let's see here. PID to kill. Okay, let's check out what else we got here. So case 1. There's like a whole bunch of stuff in here. Memset, rotate right, sysbind. Rotate right, connect. What did it say case 1 was? UDP null flood. Do you think that's right? Case 5, socket, struct socket address, bind, rotate right, connect. You'll trust the clanker on those, yeah. Case 5, what does it say? UDP random flood. 6, okay, let's see. Get advisory info. Maybe this is like a 40260D0 case 8. Or wait, that was case 6, right? Case 6. Raw UDP IP spoofing. How does it know that? Maybe it's the, oh, okay, because it's setting this 0 header, or setting this in the IP packet. I should probably figure out how to reverse these. Get sock name, raw UDP with IP spoofing. Okay, well, let's see if I can figure out the UDP piece. Yeah, maybe this is like a random seed algorithm, and I just assumed it was an identifier. Don't have any clankers on here. What does this function? Okay, probably, yeah, let's just call it rand arena.ai. Oh yeah, I could use arena. That's pretty cool. That's a good idea. Okay, send to. It's a pseudo random number generator. Yeah, that makes way more sense than what I was saying. I'm just not used to the Linux stuff. So prng, and then get prng, and then this gets a prng byte. Rotate right. Let's see here. Okay, it's just sending random data, and then the set socket option is probably setting it to UDP, which is how I probably knew that. Opus 6 was just 4.6 was released. Nice. Okay, so I've been drinking water and coffee, so I'm just gonna run to the washroom again. But again, if y'all want to check out the reason I can do all these free streams and why I can hang out with y'all during the day like this is because I run this company called Invoke RE. We do malware analysis training and services. So if you're interested in learning how to use IDA and Binary Ninja to reverse engineer malware, definitely check us out. So I'm just going to run a quick commercial for that, and then we'll continue with this. So be right back. Hey everyone, my name is Josh Reynolds, and welcome to the Invoke RE Introduction to Malware Binary Triage course. Throughout this course, you will learn to triage and reverse engineer malware binaries using a number of proven techniques. These include static analysis, which is the concept of analyzing malware at rest, and dynamic analysis, which is the concept of analyzing malware as it executes. We will also be analyzing network protocols used in malware command and control communications, malware obfuscation, packers and how to unpack them, process injection, how to write effective YAR rules to detect malware variants, and how to compare malware samples at a binary level. This course consists of 11 modules, each containing lectures and practical labs to apply knowledge that you have gained as you complete the course. We provide both video and written materials, so no matter what your learning style is, you can complete the course successfully. Thank you for checking out the course, and we look forward to teaching you. All right. Man, it's so hot in here because of this computer. It's like way hotter than the rest of my place. Let's see what else we can do here. Okay, so I was just getting this guy. We're pretty like obviously we're not done, but if we're just reversing these commands and then we got the backup C2 source, I kind of want to check out the persistence. So maybe we'll do that next instead of just looking at this TCP and UDP flooding stuff. Okay, this is what I was not sure about earlier. Let's see. Protocol level. Raw. Yeah, I don't think this is it. But this is going to be our target IP address. Cool. And that it's literally constructing the, I believe this is the IP packet on the fly. Wild. Okay. Let's say rand UDP flood. I don't know if this is UDP, but what was 6? Oh, with IP spoofing. Cool. Let's see. Do you go to conferences outside of the US? Because there's BotConf in France, and it sounds right up your alley. Yeah, I've never been to BotConf, but it looks pretty awesome. And yes, I've been to conferences outside of the US. Well, I'm in Canada, so I've been to Recon in Montreal, which is outside of the States. What have I been to in Europe? I don't think I've been to any conferences in Europe, actually. Yeah, like I've been to work stuff in Europe, but no conferences. But yeah, I've heard really good things about BotConf. Obviously, it's in France, which is super beautiful. And they change around spots every year. I won't be going this year just because I'm trying to get stuff done for Invoke RE, but definitely highly suggest going if you can. And if you can afford getting over there. Looks like it's in Angers. Oh, sorry, 2026. Where's 2026? In Reims. Reims. I don't know how you pronounce that, but yeah, from what I understand, it's really high quality. So, are you gonna go? QNIS overload. Okay, let's see here. Multi-threaded UDP, TCP custom flags. Okay, yeah. So we don't really need to reverse all of these different cases, but it looks like they're all denial of service related. And then it like creates a bunch of data and then sends it. I still don't know what those globals were used for, though. But yeah, let's look at the persistence, because that's obviously important, which is here. Let's say architecture. But then, when you get a chance, try Opus 4.6. They let you try it for free. Cool. Probably depends if my job finds ticket for me, which I'm joining in 11-ish days. Nice. That's awesome. Okay, let's see what this is doing, because I haven't reversed this yet. So set SID, change directory, open deb null, file descriptor, so current PID. This looks like it's overwriting current file. Let's call it path fd, and then deletes it. So I think this might be overwriting. Does dupe2 just duplicate the file descriptor? Yeah. So file descriptor, but is that just, what is p control? PR. So many new commands. Operations on a process or thread. Okay. Wait for, sorry, I'm just trying to figure out what this is doing. Instance lock. Okay, so I think maybe this is the persistence. So it copies itself like we saw before. But how does it actually get it to run on startup? Like it won't just run because it's in var run, right? Runtime variable data. Okay, yeah, no. Looks like it's just a like a log directory. What was the, if you're still around Portbuster, what was the persistence function that you found? Re-execute. Okay, let me take a look at, there might be something obvious that I'm missing in the strings. We haven't covered this yet, but this might be related to the flood commands that we haven't covered yet. SSDP discover, socket, let's see here. Yeah, I bet this is another command. Okay, let's keep going. I just want to see anonymous. That's weird, yeah. Okay, so they're trying like a whole bunch of stuff. Looks like PRI HTTP, SSH, header type probably. Hello. Holy, there's actually like way more code in here than I thought. Is it actually resolving this? If string and string, maybe it's checking if it's on that type of domain. Did you get, I think it was sub 402FD0. Gotta go to Josh, have fun. Thanks. Yeah, I appreciate you hanging out and all your help. Yeah, I'll take a look at those functions. Parse token, let's see here. While access, read. Oh, okay, here we go. Yeah, I think. So etc is for use with the administrator. Okay, yeah. Okay, so here it is. Okay, so basically those are our persistence files that I mentioned earlier, this bin.sh, .sh. So that's why it looked so suspicious earlier. And then they set up persistence in the rc.local. Is r plus going to give write access? And then, okay, yeah, it writes a little shell script here. Cool. Pretty straightforward. So yeah, those were persistence points at the beginning. Cool, that's kind of like all I really wanted to find. So what do y'all think I should do next? I can keep looking at the commands if we want. Sys set scheduler. It sets the scheduling policy for threads. Okay, so it's not super important, but wait, copy, let's see here. Okay, cool. I think that was like largely what I wanted to do today. We got like the gist of what this is doing, how it sets up persistence, how it communicates, how it gets up like backup C2 channels from that HTTP address /domain. I can finish reversing those commands, but yeah, they largely looked like they were DOS related. So I don't know if that'll take me a while, just because reconstructing the IP headers and stuff. Let's see. Yeah, we could probably, I don't know if I'll do another stream on this, but there's like 10 or so more commands that I haven't looked at 100%. We could probably wrap it up for today, and then we'll continue with this next time, I think. That would probably be something that we could do. But yeah, learned a lot about Linux malware. We'll probably keep doing stuff like this just so I can get used to the operating system nuances and how these things work. I will upload this VOD as soon as possible to our YouTube channel. I'll just link that in case people here. And then I'll also be posting these notes and this IDB and all of our samples and stuff here in the premium part of the training area, if folks want to take a look at it there. But yeah, really appreciate everybody hanging out. Let's raid somebody. Since we got raided today, we can pay it forward. So Twitch, or actually InfoSec streams is usually pretty good. Bicepa, there's us. mchow01. Let's check them out. DDoS taking down the internet. Episode 3, season 12. Hacker of the very old school variety. That's cool. Okay, let's see. I don't know what they're up to today, but this looks great. So I'll send y'all over there, but really appreciate y'all hanging out again. And not sure if I'll be streaming next week, but actually before I go, I'm just going to throw a link to our Discord. We just have it invite only to like keep up bots and stuff, but I'll always post this in the stream. So there's that. if anybody wants to join the Discord and hang out after this. And let me set up the raid and then we'll call it for today. See ya. All right, that worked. All right, take care, y'all. I'll see you soon.